So with that, George Wilson, thank you.
All right. Thank you, guys. So how many people are familiar with libshare or have done work in libshare? Okay. Those are the unlucky few that have kind of gone into areas that are strange. So I know, like the title for this was libZFS or libshare is broken in Linux. I kind of like to say why libshare. There's a lot of frustration that we've encountered as we started dealing with kind of using share NFS in Linux, and so this talk is going to kind of focus on some of those things. So a little bit of background. How many people are using the share NFS property to actually do NFS sharing? Okay. Is there anybody using the share SMB property for sharing? Okay. Yeah. Lucky you. So our product actually uses share NFS pretty extensively. We have that as the mechanism to export our NFS file systems out to the environments where we're serving up data. And so when we started looking at doing the transition between Linux or Illumos to Linux, one of the things that we encountered was like, well, what are we going to do with existing customers that have these share NFS properties? So it was natural for us to just simply say, we're just going to carry this over and we have to deal with it, and hopefully it all just works when you get to Linux. As we started digging into it, we found that, well, it doesn't all just work. So there are some really interesting things about the libshare implementation in Illumos that we kind of take for granted when we started looking at it from Linux. For example, it's got like built-in locking. So, you know, our product has like hundreds of threads that are simply all going out and trying to share different file systems at one time. Libshare on Illumos just handles that. On Linux, totally falls apart. So it also is very tightly coupled with NFS, which had some really interesting things, and I'll go into like why that was critical for us and kind of what we're doing to deal with it. So our journey into using share NFS on, we kind of encountered like three main problems. The first I kind of alluded to was concurrency issues. We would lose shares that would actually be exported out because they're trying to update both this the share tab, which is in like etc DFS, and this is a carryover from the Illumos implementation. Really, on Linux, it doesn't use it other than the code is trying to use it. So I think part of the problem here is that we have like this extra file that really isn't necessary on the Linux implementation. On FreeBSD, my guess is this is probably not used. Does anybody, does it use the share tab? Do you know, Alan?
No,
okay.
An exports file.
So that was one of the things that we encountered. We actually found this to be a problem, and like for us, the simple solution was like, okay, we'll just add some file locking in here. It's kind of a coarse grain lock, but we'll serialize access to this file so that it can be, you know, up to date and doesn't go stale. We then started finding like scalability issues, where like if you had a lot of file systems, we quickly found that the Linux implementation of libshare would like constantly be reading proc self mounts over and over and over. So much so that like, you know, just doing a simple share of a file system could take minutes, just doing nothing but reading this on a repeated basis. And what we encountered was that part of the implementation there is not leveraging some of the built-in caching that was put into libshare. So even the Linux implementation has logic to do caching, but it simply wasn't being enabled because there was a new object that was being allocated and it had forgotten to carry that property of enabling the cache on the new object. And then the last, which was really the most critical one, and the one that I'm going to spend the most time talking about, was stale file handles. So out the gate, if you're using this, you may not necessarily encounter stale file handles. But there are certain circumstances where you can see this, especially if you have a lot of file systems on Linux. The first case where we encountered this was just simply rebooting the NFS server. So if you rebooted the NFS server, you could get into situations where all of a sudden your client would try to do a mount and it would get a stale file handle, and then shortly later, if you tried to do the mount again, it would succeed. So it's kind of a very intermittent problem, and I'll go into exactly why this happens. So first, let's talk a little bit about the way that we actually do kind of the coordination between NFS and ZFS shares on Linux. So on Linux, we're using systemd, and the server setup is kind of looks like this. We have NFS mount D, or sorry, the first one should be NFS config D, then NFS mount D, which has like RPC mount, and all those are dependencies of the NFS server. This is where like NFSD is actually run, and then ZFS share depends and runs after the NFS server. So you look at this and you're like, okay, that kind of makes sense. ZFS share is simply going to do a ZFS share-A, share everything out, and every time we share, we're actually calling export-fs-i. So we're actually adding the exports one by one as it kind of traverses. Not super optimal, but it should just work. The problem we encounter is if you restart this component. So by restarting the NFS server, we're actually restarting this entire chain. And if at some point in time after RPC mount D is up, a client tries to do a mount, before the share has actually run, it'll come back and say, I know nothing about that share, so that obviously doesn't exist, and I end up with a stale file handle or permission denied. And then sometime later after this completes, if you try the mount again, it succeeds. So this dependency graph that we currently have in the Linux product today is missing this use case. It can't handle it today. Any questions on, yes?
Is this the exact same story for V4 versus V3?
So the question is this the same story for V4 and V3? Yes. So the same thing will happen. Now, one of the questions that I have for those in the FreeBSD world is there a similar gap in that platform? And I don't know if folks, I haven't done enough investigation, but it would be very interesting to see if this, and we'll go into a little bit more detail. So, so the first thing we thought of is like, okay, let's just reorder this. Let's just simply say, okay, well, we'll take the ZFS share service and we'll make it run first. So we'll put share at the beginning. That way, when this starts, we run them in this order. We'll share out. Then we'll start RPC config D, mount D, and then so forth. But the problem here is that ZFS share does an export-fs-i, and the NFS server on Linux does an export-fs-r, which doesn't look at anything that's not in the etc exports file. So all these exports that are done simply are ignored by the time you actually start the NFS server. So this was kind of like a case where it's like, okay, even just simply reordering doesn't necessarily work. We have to do something different here. So as we kind of thought about this, you start to kind of build this set of requirements before we actually moved into our solution. And the thing that we encountered was that we need the share NFS logic to actually run before mount D and NFSD start. So that was one of the things that we needed in order to be able to handle this particular case. And we need to somehow closely tie them so they work in unison with each other, which was something that was really convenient in the Illumos libshare case. But when we start looking outside of Illumos, libshare really is kind of a hindrance for most platforms because not everybody has the same luxury of having that close tie. So whatever solution we eventually end up with, we want to be able to work across multiple platforms that don't have this close tie between ZFS and NFS. So our solution was, well, we'll utilize the etc exports mechanism that exists. That way we don't have to change the NFS service. We know that the NFS service always looks there. So maybe we can leverage this because it's automatically consumed by the NFS service when it starts. And so then we thought, well, okay, what if instead of doing like a ZFS share-A, which is sharing out each file system one by one, we already know how to convert the share NFS property to something that Linux can interpret for export FS. So why not have something, and we came up with this, which is not set in stone, a generate flag for ZFS share that simply generates an export-like file that can be consumed by NFS directly. So a very platform-specific type of implementation that can then be used by NFS and would create a file that gets run and invoked whenever you need this. So this particular file would generate something that NFS service could consume, and then it actually turned out to be much faster, and I'll talk about some of the performance aspects of this compared to ZFS share-A. And at the same time, we said, okay, well, let's introduce some kind of cleanup service at the end that can deal with this. So we effectively have like a start point that does some work and an end point after NFS is finished running. And it kind of looks like this. So again, we have kind of like this dependency graph where we have the share service at the end now is running a ZFS share-G to generate something that NFS service can run, and some cleanup service at the end that simply is going to remove it. And what we chose to use is, in Linux, there's the concept of having an exports.d directory where you can specify and put files in there that get consumed by the NFS server. So we have a zfs.exports file that gets generated by the ZFS share-G, and then just simply gets removed after it's been consumed by NFS server. We thought, okay, well, let's try this. And it worked mostly. But we found that, well, okay, there's still gaps here and there's still holes. And there's really kind of this large failure window that can occur because we can generate the exports file here, but during the time that between that and the time that NFSD is actually up, if somebody else comes in and runs a ZFS share NFS on and tries to share and export a file system, it wasn't covered by the time we generated it. It was done sometime in the middle, and it gets lost. So we were still seeing these cases where you could have a restart of an NFS server. So this is a slightly different case. You restarted the systemd service. You generated it, and at the same time, your application is simply just trying to share a new file system. And if it tries to share the new file system somewhere in the middle, then by the time the client tried to mount it, it would still fail. So we kind of went back to the drawing board and said, okay, well, we need to figure out how we close this gap. And to do that, we said, okay, well, we have kind of this endpoint service, which we were calling a cleanup service. Why not add more logic there? We know that at the very beginning, we're generating all the exports that existed at the time that we restarted the service. If at the end, we simply regenerate what's left, we can compare the two and make a determination if there's new file systems that need to be added. And then we'll introduce an exportfs-A to cover all the use cases, not only what's in Etsy exports, but any exports that may have been done manually without adding them into the file. And that's kind of where we ended up. There's still issues here. So this is kind of like gotten us 98% of the way there, but it isn't totally complete. And so one of the things that I'm really interested in here is how to deal with this when we look at other platforms like FreeBSD, Mac OS, Windows, where we are just another file system and have to deal with the dependencies of NFS, and in the future with SMB. How do we deal with that to make sure that we're playing nicely or they're playing nicely with us? So I think this is kind of like there's more investigation to do here, and I'm interested to find out if people have run across issues in this or come up with other solutions. So this is what it kind of looks like, kind of completing the chain. We added more logic to this cleanup. So really, you can kind of think of this as like there's an initialization of the sharing, some NFS work, and then some cleanup work or FINI that actually happens at the end. That's kind of the model we're looking at to try to close the gap. But again, we're interested to see how that plays with other file systems and what other people have done. Looking at the performance, I mentioned that we found that ZFS share-A was incredibly slow. So I was doing some testing on a system that had 60,000 file systems. Running ZFS share-A took 6,009 seconds. This is like almost 2 hours. Doing the same thing with ZFS share-G took about 3 minutes. So huge difference in what is actually happening under the covers. And again, I think there's a lot of pieces that stem directly from libshare and its inefficiencies, and things that we're going to go off and tackle. Right now, we've just kind of implemented this workaround for our product. Much of the things that I've talked about here are not upstream just because they are pretty hacky. And we're interested, again, in feedback from the community. So future work, we're looking at kind of like redefining what libshare is all about. If we look at what libshare did for Illumos, which is actually pretty nice, it's not possible to accomplish the same thing on other platforms. We just don't have the same luxury. So with that in mind, we're trying to think of what libshare really should do. And it might be a very simple type of approach of like, you call into libshare, each platform kind of defines it for platform-specific components, and it knows how to do things like export a file system, however you choose to do that. It knows how to find if a file system has actually been exported, however you choose to do that. It knows how to talk to the system services, whether it's talking directly to Mount D or killing Mount D or restarting Mount D. Whatever it needs to do, it kind of gets all handled in libshare. But the way it's implemented today, I think we have, as a community, tried too hard to make libshare look like Illumos libshare. And we need to now say, okay, what Illumos has is kind of an exception. What we need for the other platforms really is what's going to define the norm and how we need to implement these going forward if we want share NFS properties to work kind of seamlessly across platforms. So that's going to be the thing that we're going to be focusing on. For Linux specifically, we're going to be using the export.d directly. We have some ideas here based on the work that we've already done. And we're kind of kicking the SMB problem down the road, because one of the things that libshare did provide in Illumos was a common mechanism to share not only NFS, but SMB. And we don't want to solve that problem just yet. So first phase will really be focusing on NFS directly. Okay. So with that, questions on kind of what we have.
Yeah, it's a good question.
Yes.
So on previous D, we did almost what you described here. We have an extra exports file that our MP reads, and so when you NFS share-A, it writes a line in the file for each shared file system we have, and then reloads MP.
Yeah, and I actually took a look at the FreeBSD implementation based on your feedback, and I think that design makes perfect sense.
So I was curious why you were removing the file from the export.d directory.
So one question was, why are we removing the exports file as a cleanup phase? And the main reason that we do it in this implementation is because that file isn't getting updated in place when other shares come in. So we didn't want our support organization or anybody else that was looking at the system to look at this and say, oh, the reason it's not exported is because it's not in the exports.d file. Well, that's true, because that file gets generated, consumed, and then goes stale. So that's why we remove it.
It's source of truth.
Yes, in the future, the plan is that file will stay and it will get updated in place. It will have all the information. So effectively, for Linux, it's taking the place of what the share tab was doing, really will now live in an exports file. And we have, we've looked at things like to avoid locking, because we have this directory, what if like every file system that you share has its own file? So then you don't have to worry about locking it all and do file locking and kind of make this even faster. So those are some of the ideas we're playing around with. But I would be interested to see if like there is kind of a similar window of vulnerability or lack of or lost mounts on FreeBSD.
Not lost mounts, but years ago we had a problem that our Mount D would, when you reloaded it, would unshare everything and reshare everything. You had 6,000 file systems. So it'd be a window where.
Yes, which is exactly what Linux does. It actually unshares everything and then reshares everything.
Adam, I think
You're eating into your time, so come on up here. Thanks, George.
All right, thank you.